More quadratic equations. First, let's talk about the square root property. If a squared is equal to b, where b is a real number, then a equals positive square root of b, or a equals negative square root of b. Let's verify this property. So if a squared is equal to b, and if we take the square root of both sides of the equation, there is a tricky step that happens in here. The square root of a squared is the absolute value of a. And if the absolute value of a is equal to some number, then a can either be positive or negative of that number. So we end up getting a is either equal to positive square root of b, or a is equal to negative square root of b. So we can use this property to solve the following equation. 2x minus 3 quantity squared is equal to 25. Now you might notice that this does not look exactly like what the property says, but it is some quantity squared is equal to some other quantity. Now, to be totally honest with you, when I have a problem like this, I don't usually just use the property on the previous page. What I will normally do is take the square root of both sides. And then when we do that, we can see that the square root and the square cancel out. And then instead of putting the absolute value here, I'm just going to put plus or minus 5 on the other side. So now when I add 3 to both sides, we get 2x is equal to, now how do we add positive or negative 5 plus 3? Well, actually, we're going to write down the number 3 and then plus or minus 5. And finally, when I divide by 2, we end up getting x equals 3 plus or minus 5 divided by 2. And there's two answers here. 3 plus 5 divided by 2, which is 4, and 3 minus 5 divided by 2, which is negative 1. So we get two solutions. Now, it is true that if you use the square root property, you could have gotten here a little bit faster, right? So we could have simply said, well, we know that 2x minus 3 either equals the square root of 25 or 2x minus 3 equals negative square root of 25. And that would be, of course, 2x minus 3 equals 5, which gives us 2x equals 8, or x is equal to 4. And for the other equation, 2x minus 3 equals negative 5, which would then give us 2x equals negative 2, or x is equal to negative 1. And we have the same solutions. But I find that students sometimes don't find it very easy to go from here to here. So that is why I prefer taking the square root of both sides and doing it the first method that I showed. Let's talk about the Pythagorean theorem. So this is a theorem from geometry. If we have a right triangle, which is a triangle that has a 90-degree angle, the two sides of the triangle that make the 90-degree angle are called the legs of the right triangle. And in this case, one leg is A and the other leg is B. The side of the triangle that is opposite the 90-degree angle is called the hypotenuse. And we know that in any right triangle where the legs are A and B and the hypotenuse is C, we know that C squared must be equal to A squared plus B squared. And this is perhaps the most important theorem in all of mathematics. So this is a really good theorem to remember. Okay, let's take a look at an example. So table 1 in this section of the book says the vertical rise of the Forest double chair lift is 1,170 feet, and the length of the chair lift is 5,750 feet. Find the horizontal distance covered by a person riding this lift. Okay, so a ski lift basically takes you from a point A, which is lower, up to a point B, which is higher. And we know that the total distance travel is 5,750 feet on this lift. Now, if I construct a right triangle here by drawing the legs perpendicular to one another, so we have a right angle, the vertical rise of this chairlift is 1,170 feet. That would be this part right here, right? Because the vertical rise is the vertical change in the distance from where you started to where you ended. So the question is, what is the horizontal distance covered, this distance here? So we'll call that distance x. And then we know from the Pythagorean theorem, since this is a right triangle, x squared plus 1,170 squared must be equal to 5,750 squared. And then we can solve for x by using the square root property. But first, we have to multiply out 1,170 squared, right? So when you square that number, you get a pretty big number here. You get 1,368,900. And 5,750, if we square that number, we get 33,062,500. Okay? So now to solve for x squared, I'm just going to subtract 1,368,900 from both sides. Now, of course, it's probably best to use a calculator to do this, so let's go ahead and do that subtraction on a calculator. This is going to give us 693,600. And so we know that x is either going to be positive or negative the square root of this number. But the negative square root doesn't make sense, right? Because x is a distance, and we can't have a negative distance. So I'm just going to take the square root of that answer. And if we do this and round our answer, we have 5,629.7 feet. So the approximate horizontal distance traveled is 5,629.7. Next, let's talk about a concept called completing the square. So first of all, let me give you an example of a trinomial like x squared plus 6x plus 9. And if we were to factor this trinomial, notice that we would have x plus 3 times x plus 3. You could verify that. And we could write this as x plus 3 quantity squared. So this trinomial right here is what we call a perfect square trinomial. Now, the reason we call it a perfect square trinomial is because it factors into a perfect square, right? We have something squared. But not all trinomials are perfect square trinomials. So what is it about this that made it a perfect square? Well, two things. Algebraically, the number 3, right? 3 plus 3 is 6, and 3 times 3 is 9. So the fact that these two numbers, 6 and 9, are the sum of 3 and 3 and the product of 3 and 3 is why this was a perfect square trinomial. Okay? So for example, if I had x squared plus 10x plus 25, we could verify that this is also a perfect square trinomial because it factors into x plus 5 quantity squared. Why is that? Well, because 5 plus 5 is 10, and 5 times 5 is 25. But there's a little bit more happening here, geometrically. So if you took x plus 5 times x plus 5 and tried to represent that using geometric figures, what we could do is we could break this up like so, and we could say the distance here is x units, and the distance here is 5 units, and down here, same thing, this is x units, and the distance here is 5 units. And the 5 units, if we divided that up so you could actually see all 5 units, so notice here we have 1, 2, 3, 4, 5. And if I do that the other way as well, so just dividing this up. So to be perfectly clear, the distance from here to here is x, and then this is 1 unit, 1 unit, 1 unit, 1 unit, and 1 unit, which gives us a total of 5 units. Same thing here. Notice that the area of this big square is x squared. The area of each one of these squares is x, okay? So this x that I'm putting on the inside, that represents the area of each one of those. I said square, I meant rectangle, okay? Now, the reason for that is because each one of these is 1 unit, and then this is x units. And so the area of this is 1 times x, which is x. And then these little squares down here, these are all 1 unit by 1 unit. So every single one of these little squares has an area of 1 unit, okay? So it's a little bit tedious here. But if I added up the total area of all of these squares and rectangles, we would have x squared plus how many x's? Well, there's 5 x's here and 5 x's here, so that would be 10 x's. And then how many little squares down here? 25 total little squares. So the total area is that. But we also know that the area can be found by doing the length times the width of the overall shape here. And x plus 5 times x plus 5, of course, is x plus 5 squared. So the reason we call this a perfect square trinomial is because it makes a perfect square here, okay? All right, so now the question is, what if you don't have a perfect square? So what if instead of x squared plus 6x plus 9, what if this 9 was a different number? Like, how could I make it a perfect square? So this is where we start talking about completing the square. So what if I gave you x squared plus 8x, and I asked you what number would I have to add here to make this a perfect square? So remember, the number in the middle, we want to think of that as the sum of two numbers, and the number on the end, we want to think about that as the product of the two numbers. Well, we know that 8 is 4 plus 4. So if we want to add the same number to get 8, it has to be 4 and 4. So on the end, we would have to have 4 times 4. So to complete the square here, I would have to add 16, okay? And then if I did that, this would now factor into x plus 4 times x plus 4, which we could write as x plus 4 quantity squared. So what's the shortcut? Well, here's the shortcut. To figure out what number we have to add to complete the square, we simply take the middle number, which in this case is 8, we divide it by 2, and then we square it. And that is how we get this number. And this will work no matter what the number is. So for example, if I have x squared plus b times x, and I want to know what number do I add to complete the square, we take the middle number, which is b, we divide it by 2, and we square it. So the correct number to add here would be b divided by 2, quantity squared. And that's the formula for completing the square. Now, one other thing I have to say is that this only works if you have a 1 in front of your x squared here. So if you don't have a 1 in front there, then we have to do something else first. So now we're going to take this technique and we're going to use it to solve this problem. So we want to solve x squared minus 6x plus 5 is equal to 0. We want to solve this by completing the square. So I have x squared minus 6x plus 5 is equal to 0. Notice that this is not a perfect square. So what I want to do is make it a perfect square. So first thing I'm going to do is say that we need to have the correct number here on the end to make this a perfect square. 5 is not the correct number. So let's get rid of the 5. And I could do that by simply subtracting 5 from both sides. So now I have negative 5 on the right-hand side. And then I'm going to add the right number here. Well, if you take the middle number, which is negative 6, and you divide it by 2, and you square it, this is equal to positive 9. So I am going to add 9 to the left-hand side, and I'm going to add 9 to the right-hand side. So now on the left-hand side, we have completed the square, which means that we can now factor this. And when we factor it, it's going to become x minus 3 times x minus 3. Left-hand side becomes 4. Excuse me, right-hand side becomes 4. And on the left-hand side, we now have a perfect square, right? X minus 3, quantity squared, is equal to 4. So now to solve this the rest of the way, all I'm going to do is take the square root of both sides. On the left-hand side, we're going to have x minus 3. On the right-hand side, we're going to have positive or negative 2. And so now x is going to be 3 plus or minus 2, right? Because I'm just adding 3 to both sides. And that gives us two solutions. We have one solution, which is 3 plus 2, which is 5. And we have the other solution, which is 3 minus 2, which equals 1. So we have two solutions, x equals 5 or x equals 1. Okay. Now, a comment that I have to make here is that you can solve this equation without completing the square. In fact, let's do that real quick. How could we solve that without completing the square? Well, we could just try factoring it, right? Turns out that this is pretty simple to factor. So we know that the factors of 5 have to be 5 and 1, and they have to both be negative in order to get negative 6 in the middle. And you can check it out, but that works, doesn't it? So now if I set each of these factors equal to 0, I'm going to get x equals 5 and x equals 1. Notice that these are the same two answers that we got using completing the square. And this is much easier, right? This is much easier. So why are we learning completing the square then? Well, we're learning completing the square because sometimes you will not be able to factor the quadratic, okay? And if you can't factor, then you need a method for solving that equation. So let's take a look at this example. Solve by completing the square. And I just want to point out that you cannot factor this, right? There are no factors of 2 that will make 5. So if you tried to factor this, you would not be able to factor this. So we're going to start by simply writing down the problem. X squared plus 5x minus 2 equals 0. The first step in completing the square is let's get rid of the number that is there, because that minus 2 there is not the correct number to have a perfect square. And now I'm going to add in the correct number, right? So we need to figure out what is the number that I need to add there. Well, again, you take the middle number, which is 5, divide it by 2, and square it. Now, 5 divided by 2 squared is 25 over 4, okay? Which is not a very nice number, but that's just how it goes sometimes. So I'm going to add 5 over 2 squared to both sides of the equation, and then I'm going to clean this up a little bit. So on the left-hand side, I can now factor this. It's a little bit strange, but we're going to have x and x. We're going to have positive and positive because the middle number is positive there. And then what number do we put here and here? Well, it's this number. It's 5 over 2. Okay? On the other side, we have 2 plus, and then I'm going to actually multiply it out on the other side and say 25 over 4. And then I'm going to get a common denominator, which is 4. And that is going to be 8 over 4 plus 25 over 4, which is 33 over 4. And on the left-hand side, we have x plus 5 halves multiplied by itself, so x plus 5 halves squared. All right, now, how do we solve for x? Well, let's go ahead and take the square root of both sides. So on the left-hand side, we're just going to have x plus 5 halves. On the right-hand side, don't forget you need to put plus or minus. And I have the square root of 33 divided by the square root of 4, but the square root of 4 is 2. And then for our last step, we're just going to subtract this in front here. And so that's going to give us x equals negative 5 halves plus or minus the square root of 33 over 2. And these are our answers. Okay, now there's two answers there. We have negative 5 halves plus radical 33 over 2, or x is equal to negative 5 halves minus radical 33 over 2. Now you can write your answers all in one like this. Sometimes when you do this on a computer, it will make you put the answers separate from each other. But notice that the answers are not very nice, right? They're not whole numbers. They're not simple fractions. They involve irrational numbers, like radical 33, for example. This is why we need completing the square, because there's no way to solve this equation here by factoring. So next, how to solve a quadratic equation by completing the square. So we have some steps. First thing you want to do is write the equation in the following format. Okay, so that's just basically getting rid of the number that is not making it a perfect square. If the leading coefficient is not 1, so if the number in front of x squared is not 1, you have to divide both sides by that coefficient. Now, I haven't done an example of this yet, but I'm going to do one here in just a second. And then you go ahead with the rest of it, which is complete the square, and then write it as a square of a binomial, and then apply the square root property. So let's take a look at one more example before moving on. So in this example here, notice that we do not have 1x squared. We have 6x squared. So this is going to be something that we have to take care of before we complete the square. But the first step is go ahead and get rid of the number here. So I'm just going to add 6 to both sides. And that gives us 6x squared plus 5x is equal to 6. Now my next step, I'm not ready to complete the square yet. So if you take half of 5 and you square it, that's going to be the wrong number here. And that's because we don't have a 1 here yet. So what we're going to do is divide both sides of this equation by 6. So what that does is it gives us 6x squared divided by 6 and 5x divided by 6. And then, of course, on the other side, 6 divided by 6. So we get a little cancellation here. We get a little cancellation here. So that gives us x squared plus 5/6 times x is equal to 1. All right. Now I have a 1x squared, so now I'm ready to complete the square. So to complete the square, you take the middle number, 5/6. Now, usually you divide that by 2, and then you square it. But because this is a fraction, instead of dividing by 2, let's multiply it by 1/2, and then we'll square it. And so this is 5/12 squared. That is the number that I need to add to both sides to complete the square. Okay, so what happens next? Well, now we can factor this using the idea of a perfect square. So we're going to have x and x, positive and positive, and this will be 5/12 here, and this will be 5/12 here. On the other side, I'm going to change 1 to be 144 over 144. And the reason I did that is because 5/12 squared is 25 over 144. So that gives us a common denominator. On the left-hand side, we have x plus 5/12, quantity squared. On the right-hand side, we have 169 over 144. And now if I take the square root of both sides on the left side, x plus 5/12. On the right side, plus or minus 13 over 12. The square root of 169 is 13, and the square root of 144 is 12. So then our next step is we're just going to subtract that over to the other side. So x is going to be negative 5/12 plus or minus 13 over 12. Notice we have very nice answers here. We have negative 5 over 12 plus 13 over 12, which is 8 over 12, which is 2/3. And the other answer is negative 5 over 12 minus 13 over 12, which is negative 18 over 12, which is negative 3/2. So our two answers are 2/3 and negative 3/2. And notice that these answers, even though The process was pretty terrible. The answers are nice, right? There's no radicals in our answer. And that was because the square root of 169 and the square root of 144 were whole numbers. So what does that tell us if the answers are nice here? Well, I'll tell you what that tells us. It means that we didn't have to solve this using completing the square. We could have solved this by using factoring. So let's redo this problem real quick, just showing you how factoring will work. So I could factor this by multiplying those two numbers together. So 6 times negative 6 is negative 36. And of course we have 5 in the middle. And now the two numbers that I can multiply to get negative 36 and add to get positive 5 are positive 9 and negative 4. So if I go to factor this, using the magic x method, we're going to have x plus 9 and x minus 4. Don't forget, if you have a number other than 1 in front of x squared, you have to divide each of these by that number. Then simplify, so this becomes x plus 3 over 2 and x minus 2 over 3. And the final step, we're going to move these in front. And this gives us 2x plus 3 times 3x minus 2. And if you solve each one of these, here you are going to get x equals negative 3 halves. And here you will get x equals positive 2/3. So again, this is much easier, right? It's easier to factor than to complete the square, which is why factoring is so important, because we don't want to force ourselves to have to complete the square every time we want to solve a quadratic equation. So next we have what's called the quadratic theorem in this book. Usually, to be totally honest with you, it is called the quadratic formula. And this will be a formula for solving quadratic equations. So anytime you have an equation, ax squared plus bx plus c is equal to 0, as long as a is not equal to 0, you can get the solutions by using this formula. Now, most of the time, the way they will state this is they will say x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And I'm pretty sure that you have probably seen this formula before. So what is this formula used for? Well, again, if you're trying to solve a quadratic equation, if it does not factor, this formula will help you solve that equation without having to complete the square. Let's take a look at an example. So here we want to solve x squared minus 5x minus 6 equals 0 using the quadratic formula. So the formula says x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So the first thing we need to do is figure out what is a, what is b, and what is c. So a, of course, is the number in front of x squared. So a is equal to 1. B is the number in front of x, which is negative 5, and c is the constant term, which is negative 6. And then I just plug those numbers in. So we have negative b, but b is negative 5, so that would be negative 5, plus or minus the square root of b squared, which is negative 5 quantity squared, minus 4 times a is 1, c is negative 6, make sure your radical goes all the way over, and then the whole fraction is divided by 2 times a, and a is 1. Now we're just going to do the arithmetic. So negative 5 is 5. Inside the radical, negative 5 squared is 25, right? And then negative 4 times 1 times negative 6 is positive 24 divided by 2. This is 5 plus or minus the square root of 49, all divided by 2. And this is really nice because the square root of 49 is 7. And so we have two answers, 5 plus 7 divided by 2, which is 6, and 5 minus 7 divided by 2, which is negative 1. Now again, you did not have to use the quadratic formula to solve this. Rather, you could have used factoring. So let me just remind us that if we were to factor this, we would have had x minus 6, x plus 1 equals 0. And then when you set each one of those factors equal to 0, you would get the same two answers. So again, the quadratic formula wouldn't necessarily have to be used in this example, but we learn it to be able to solve quadratic equations where we cannot factor. So let's go ahead and solve the following equation. We have x squared minus 6x equals negative 7. Now, when you get a problem and you're asked to solve it, unless you're told to do it a specific way, you can do it any way you want. So one thing you might want to do here is try factoring first. Now, this is very tempting because you see 7 and 6 and you think, well, that looks like it's going to factor. But if you really consider this carefully, using a magic x, 1 times 7 is 7. We have negative 6 in the middle. And there are no two numbers, at least not real numbers or rational numbers, that you can add to get negative 6 and you can multiply to get positive 7. So for example, if you did negative 7 and positive 1, those would add to give negative 6, but if you multiply those, you don't get positive 7, right? You can try positive 7 and positive 1, but then when you add those, you don't get negative 6. You can try negative 7 and negative 1, but again, when you add those, you don't get negative 6. So this is not factorable. So what else can we do? Well, we could complete the square, right? In fact, they already have the negative 7 on the other side there, so that's nice. So when I complete the square, I would have to add 9 to both sides, right? Because 6 divided by 2, quantity squared, is 9. And then on the left-hand side, that would factor into x plus 3 times x plus 3, which would be x plus 3 quantity squared. And on the right-hand side, we have 2. And then next, we would take the square root of both sides. And that would give us x plus 3 is equal to plus or minus the square root of 2. And the final step is we're going to subtract 3 to the other side, which would give us two answers. And we can write our answers like this, or we could say x equals negative 3 plus radical 2, and x equals negative 3 minus radical 2. Okay? So we could use completing the square. But most people don't like completing the square, to be totally honest. And so another way to do this is we could simply use the quadratic formula. So if I want to use the quadratic formula, the first thing I'm going to do here is I'm going to add 7 to both sides. And that's going to give us x squared minus 6x plus 7 is equal to 0. And then I can quickly and easily identify a, b, and c. And the quadratic formula tells us x is equal to negative b plus or minus square root of b squared minus 4ac all divided by 2a. And this is going to be negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 7 all divided by 2 times 1. And then when we simplify, we have positive 6 plus or minus the square root of 36 minus 28 divided by 2. This is 6 plus or minus the square root of 8 divided by 2. Okay, now we have to simplify this answer, and it's very tempting, and I talked about this in a previous video, but it's very tempting to want to cancel these. Please don't do that. Instead, what we need to do is simplify the square root of 8. The square root of 8 is the square root of 4 times the square root of 2, which is 2 radical 2. Now I can cancel a 2, because all three of these numbers have a 2. So 2 goes into 6 3 times, 2 goes into 2 1 time, and 2 goes into 2 1 time. And so what we have left over is 3 plus or minus 1 radical 2 divided by 1. And those are the same answers we got a minute ago. 3 plus radical 2 and 3 minus radical 2. So you have your choice here of completing the square or using the quadratic formula. Most students prefer the quadratic formula. Let's go ahead and use the quadratic formula again to solve this equation. So what we have here is 1/10 x squared minus 1/5 x is equal to negative 1/2. Two things have to happen before you can use the quadratic formula. You have to set it equal to 0, like we did in the previous problem. So if we just add 1/2 to both sides, we can easily set this equal to 0. And here's your A, your B, and your C. But those are not nice numbers, right? So what I'm going to do instead of using those numbers is I'm just going to multiply both sides by 10. Because when I multiply by 10 here, this is going to become x squared. And then 10 times negative 1/5 is negative 2, so negative 2x. And 10 times 1/2 is positive 5. That's a much nicer equation, right? And I apologize if you can't really see what I did there. Basically, I just multiplied this by 10 on both sides. And then I just moved this term over, okay? Now I can use the quadratic formula. So quadratic formula says x equals negative b, right? This is b, plus or minus the square root of b squared, minus 4 times a is 1, times c is 5, all divided by 2 times a, so 2 times 1. Simplify, we get 2 plus or minus the square root of 4 minus 20 divided by 2. This is 2 plus or minus the square root of negative 16 divided by 2. And remember, how do we take the square root of a negative? Well, that's going to be a complex number, right? In this case, an imaginary number. So 2 plus or minus 4i divided by 2. And if I divide each of these by 2, we end up getting 1 plus or minus 2i. So we have two answers. We have x equals 1 plus 2i and 1 minus 2i. And these are complex numbers. And one last thing that I will point out here is not only are these complex numbers, but they are complex conjugates, right? And that's not a coincidence. How would we solve this one? So again, when you first get an equation, you're not going to start thinking, oh, quadratic formula or completing the square. It's actually much more fundamental than that. The first thing you should think of when you get this problem is it looks like it's quadratic, right? Because x times x is x squared, and it's factored, but we don't have 0 on the other side. And so this factoring is not good. We need to multiply this out. So what we have is 4x squared minus 2x minus 6x plus 4 equals negative 4, right? So just FOIL it out. Combine like terms, we have 4x squared minus 8x plus 4 equals negative 4. Let me go ahead and add 4 to both sides. That gives us 4x squared minus 8x plus 8 is equal to 0. This is the equation that I'm solving. Now, you can use the quadratic formula, that's perfectly fine, but notice that all of these numbers are divisible by 4. Let's factor out the greatest common factor. That's going to give us x squared minus 2x plus 2. Now, all I need to do, I can ignore this part. I just need to set this equal to 0 and solve. So applying the quadratic formula, we are going to get the following. I'm going to leave this to you to verify. So what do we get next here? We have 2 plus or minus the square root of 4 minus 8 is negative 4. What's the square root of negative 4? Well, it's 2i, isn't it? So now if we divide each of those by 2, we have 1 plus or minus I. So 1 plus I and 1 minus I. Those are our answers. Okay, so none of the stuff that you learned before is ignored now. Just because we're doing it using the quadratic formula, the beginning of this problem is still exactly the same. And finally, an application. If an object is thrown downward with an initial velocity of 20 feet per second, the distance s in feet it travels in t seconds is given by the function s equals 20t plus 16t squared. How long does it take the object to fall 40 feet? So remember, s is the distance that it falls. So if it falls 40 feet, s will be 40. And if I plug in 40 here for s, we get 40 equals 20t plus 16t squared. Now, I'm going to rewrite this as 16t squared plus 20t is equal to 40. And then I'm going to subtract 40 from both sides because I want to set it equal to 0. And then now I need to solve that equation. Now again, you could just use quadratic formula with these numbers, but notice all these numbers are divisible by 4. So if I factor out a 4, we have 4t squared plus 5t minus 8. And now I can just focus on this part. T is going to be negative 5 plus or minus the square root of 5 squared minus 4 times negative 8, all divided by 2 times 4. So just quadratic formula, we're going to have 25 plus, right, we have negative times negative is positive. 4 times 4 is 16. 16 times 8 is 128 divided by 8. Let's keep going. We have negative 5 plus or minus the square root of 25 plus 128 is 153 divided by 8. And now that's going to give us 2 answers. So one answer, of course, will be negative 5 plus the square root of 153 divided by 8. And I'm going to approximate this in a calculator. And the other answer will be negative 5 minus the square root of 153 divided by 8. So now let's go ahead and plug those in. And doing so gives us 2 answers. We have positive 0.92 seconds and negative 2.17 seconds. Well, it's not going to be a negative amount of time. So the answer is 0.92 seconds. So if you throw an object at a speed of 20 feet per second downward, how long is it going to take to go 40 feet? It's only going to take 0.92 seconds. And that concludes this video lesson.